Now we're talking about the Pythagorean theorem, and the theorem says that for a right triangle, this length a squared plus this length b squared has to equal the length of the hypotenuse squared. And now I'm going to prove the theorem. And there are a lot of different proofs of this theorem. In fact, there's been a book written that collects over 300 different proofs of this theorem. I'm just going to show you one, and one should be sufficient. After this proof, you should be convinced that this theorem is necessarily true. And I'll show you a proof based on area. What I'm going to do is take this triangle and make some copies of it and arrange them to produce a large square. So I'm going to redraw this little triangle down here like this. And this length is A and this length is B and the hypotenuse is C. And let's put another copy of that triangle over here turned this way. So the short side is here and the hypotenuse is there. And then put another one here. So there's side A and B, and that's side C, and then we'll put another one here. So that's A and B right there, and C. Now we form a large square. And look at this. This length right here is A plus B. And so is this right here. That's A plus B. And this length is A plus B. And this length is A plus B. So the large outer square, I'll take note here, this square has sides that are length A plus B. And we know that the area of a square is the length of a side squared. So that length squared will be the area of that square. So it's going to have an area that's A plus B squared. So the area of this large square has to be A plus B squared. Now let's look at this area another way. This area of this large square has to be the sum of the area of all of the pieces. So this large square, in other words, is made of this triangle plus this one plus this one plus this one plus this square in the middle. Okay, all 5 of those pieces together have to add up. The area of all 5 of those pieces has to add up to the total area. So let's think about one of these little triangles down here. The area of a triangle, remember, is 1/2 base times height. But instead of base and height right here, we have this. We have A for the base and B for the height. So the area of one of those little triangles is 1/2 BH. So the area of the whole square has to be 4 of those little triangles right there. And so we'll write that mathematically. We'll say the area is 4 times this. 4 of those. 4 times 1/2 BH. Plus the area of this square in the middle. And that square in the middle is a square of length of side with sides of length C. So I'll say plus C squared. So we see 2 different ways to look at the area. If I think about this edge here is A plus B, then the area is A plus B squared. And if I think about the area of the individual pieces, the area is this. So those 2 things have to be the same. This has to be equal to this. So let's write that. Let's just write that this is equal to that and work out a little bit of the algebra. So I write A plus B squared has to equal 4 times 1/2 AB plus C squared. Now on the left, if I work out the FOIL here, if I do A plus B times A plus B and work it out, that comes out to A squared plus 2AB plus B squared. And on the right here, the 4 and the 1/2 reduce to a 2, and so I have 2AB plus C squared. And then you can see that you can subtract 2ab from each side, and that's going to cancel out. And look what's left. On the left we have a squared plus b squared, and on the right we have c squared, so we're done. A squared plus b squared equals c squared. And that logically follows right there from looking at this diagram. So the Pythagorean theorem has been proved. A squared plus b squared equals c squared.